Hey guys, welcome back to my channel. Hope you're doing extremely well, and this is a very own mass coder this side. So today's question is search in a row wise sorted matrix. The problem is actually very simple. The problem says that you haven't given a matrix, as you can see. Now each row is sorted. That is 3, 4, 9 is a sorted order, 3 less than 4 less than 9. 2, 5, 6 is again a sorted, 2 less than 5 less than 6. And 7, 8, 10 is again sorted. 7 less than 8 less than 10. So those of you who have solved the previous problem, that is yesterday's problem, you must have seen that that matrix was also row wise sorted. But in addition to row wise, that matrix, that is a previous matrix, yesterday's matrix, was also column wise sorted. But this is not the case here. You can see 9 is not less than 6, not less than 10. So 9 less than 6 is not happening. So it is not column wise sorted. It is not column wise sorted, right? So this is a modification. This is just a small modification that this matrix is only row wise sorted. This is not column wise sorted, and we have to do the same thing. X equal to 8, find it down. Okay, so let me explain you very fast because this problem requires only 2 minutes of your time. What is the brute force approach? Obviously, you will traverse the whole matrix, that is O of n m time complexity, assuming the order is n into n. You will use two nested loops, one for the row, another one for the columns, and you will traverse each element. That is, you will come across 3, then 4, then 9, then 2, then 5, then 6, then 7, then 8, and 10, and you will compare. If any value is equal to it, that is this value, will return true. Otherwise, if both the loop end and this all the elements are traversed and you don't find the required element, suppose the element is 11, you don't find the element, you will return false, right? Time complexity required will be O of n. This is time complexity, and the space complexity is O of 1. I don't need, I would not like to explore more this brute force approach, right? Because I don't think that this requires much of my time. Okay, so let us just see the optimized approach. What is the optimized approach? Obviously, the brute force approach is linear search. More or less, it is a linear search, right? But the question says search and the question says sorted. Sorted plus search. From the last previous 15 days, of, I guess, I have been telling when these two words combine, you need to think about binary search. That is the answer here also. Okay, so what are sorted? Rows are sorted. Rows are sorted. So I cannot single down to any single row. See, in a matrix, there are rows, there are columns. For each value, a unique combination of rows and columns is there. That is, for this element, row number 1, column number 1. For this element, row number 1, column number 0. For this element, row number 2, column number 2, right? Okay, so here rows are sorted. We cannot say anything about columns. Okay, so what do I need to think is that I cannot single down to single row. See, I have three options for rows: 1, 2, 3. Because the rows are sorted, so I can apply my binary search only on the rows. I can apply my binary search individually on this row, individually on this row, individually on this row, right? I cannot take the combined of both, all three of them. I cannot combine all three of them, right? So because this is sorted, so I will use only one row. How will I single out that row? So what will I do? I will just traverse all the rows. I will come to this row, that is row number 0. I will see that my answer is 8. I need to find 8, right? If this value, because the row is sorted, this is the least value, this is the largest value, right? So if 8 is lying in them, then 8 should be lying between 3 and 9, close intervals. Then only it can lie in between also. So if 8 is lying between 3 and 9, then search in this. Now how will I search? Because the rows are sorted, I will use binary search for that. I will use binary search. So I will search for, because 8 is lying in 3, in between 3 and 9, so search 8 in 3 to 9. I come here, 2 and 6. 8 is not lying in between 2 and 6, right? So I will say do not search here. Then I will come here, I will see 7, 8, 10. That is 7, 8 is lying between 7 and 10, right? 8 is contained in the range of 7 to 10. So search in this. So we have narrowed down our time complexity to, because we are traversing all the rows, so O of n for all the rows. Now because of some selective rows, we have to travel, like we have to search the element also, so it will require a log of m time in binary search. So time complexity is O of n log m, and the space complexity is O of 1. As simple as that. This was the A brute force approach was linear search. We optimize it using binary search. Time complexity became O of n log m. This question has nothing else to be given. So I guess we can end it and we can just move to the code. So here we are in the coding section. What will I do? I will first take the sizes. So int n equals to mat dot size, m equals to mat 0 dot size. Right now traverse all the rows. So for int I going from 0, I less than n, I plus plus. Our condition was that the element x should lie between the first and last element of the row. So if mat I 0 is less than equals to x and x is less than equals to mat I m minus 1, right? In that case, search. So if search for that particular row, that particular element returns true, then return true. If all the rows are finished and you don't find the element, then it means it will return false, right? Now go to implement search. So bool search vector of int arr. I'm naming it arr, and let us name it as int x. Now what will you do? So int low, simple binary search, 0 high equals to arr dot size minus 1. While low is less than equals to high, find the mid. So int mid equals to low plus high by 2. So if arr mid equals to x, return true. You have found the element. Else if two conditions can be, it is either less or greater. So int mid less than x. Int mid less than x. That is we have to find our answer in the right interval. That is low equals to mid plus 1. Else high equals to mid minus 1. As simple as that. If not found, then return false. Right? I hope it will work. Let us try to compile and run it. Working fine for sample test case. Let us see for the uh, hidden test cases as well. Working great and getting submitted. So thank you for watching. Hope you liked it and please make sure to like and subscribe to the channel. Thank you. Have a nice day.